Hi everybody. In this video, I am going to go through lesson 2.05, which is all about classifying polynomials. There we go. 2.5, classifying polynomials. Nope, polygons. And I kept saying that with such confidence too. Polynomials was last unit. So we are going to first talk about what is a polygon. Oops. A polygon is a closed geometric figure made of three or more. So made of three plus line segments in a plane. So polygons, maybe we have just a triangle or a quadrilateral. Here, I'm going to draw this quadrilateral. Here's my quadrilateral. Maybe a pentagon, except my pentagon is going to be kind of different. Ooh, here's my pentagon. That's five sides, but it doesn't look like a pentagon like you'd think. You would think of a regular pentagon, probably. So polygons have no curved lines. So if I have even part of my polygon has a curve in it, that is not a polygon. We cannot have any separated pieces. So no separated pieces. So maybe I have a shape kind of like a little crisscross with two separate sections. One triangle is a polygon, the other triangle is a polygon. But altogether, that shape is not a polygon. And no openings. No gaps. So just because it looks like a rectangle, if it has a little gap in it, that is not a polygon. So we can name polygons by their vertices. So I'm just going to say by vertices. And really, the vertices are like the points, right? The points that make up the shape. So the vertices, those are the vertexes, if you will. And so we can name polygons by really their vertices, which is the same thing as the number of sides they have and the number of angles they have. All right, so real quick, a triangle has three sides, three angles. A quadrilateral is a polynomial that has four sides or four angles or four vertices. So remember, that just means we have four vertices, we have four sides with four angles. A pentagon has five vertices. A hexagon has six. A heptagon has seven. An octagon has eight. A nonagon has 9, and a decagon has 10. 10 sides with 10 angles. So those are the main types of polygons that we have. Next, I want to talk about the difference between convex polygons versus concave polygons. So convex means really all of our angles are less than 180 degrees. So I'm going to say actually all angles are less than 180 degrees. That doesn't mean when I add them up together, it's less than 180 degrees. That means each angle is less than 180 degrees. And really, this really looks like all sides have been pushed out. So maybe I have a shape like so. A pentagon looking shape on all of those vertices have been pushed outwards. Maybe we have just straight up triangle. Concave means that one angle or more is greater than or equal to 180 degrees. Well, it has to be just greater than. So just greater than 180 degrees. Because if it is equal to, not really much of a vertex there. All right, so one angle or more is greater than 180 degrees. So here is, oh, and I forgot to tell you what this looks like. It looks like one pair of sides is pushed in. So perhaps instead of having a triangle, we have kind of this arrowhead. It's a polygon. It has 4 sides with 4 vertices. But one of these angles, this one right here, is this big reflex angle that is bigger than 180 degrees. More complex, maybe I have this shape. It's kind of going like that. Oop, I didn't mean to do that, but that's fine. And then it kind of goes like this, and then it goes like that, and then it goes like that. So this has 1, 2, 3, 4, 5, 6 sides. So this is actually a hexagon. But look, this angle here has kind of been pushed in. It is actually an angle that is greater than 180 degrees. Okay, let's talk some specifics. Let's talk triangles. So we have some different types of triangles. So we can first classify our triangles by the side lengths that we have. So when I want to classify a triangle, the first thing I'm going to do is look at the side lengths of my triangle. So we kind of have 3 possibilities here. Your side lengths produce an equilateral triangle. Your side lengths produce an isosceles triangle. Or your side lengths produce a scalene triangle. Now, equilateral means that all of our sides are the same measure, which means they're congruent. They all have the same length. In an isosceles triangle, two of our sides are congruent. Or two of them have that equal length. And in a scalene triangle, all of our sides have different lengths. So all sides are different lengths. So once we've determined whether it is equilateral, isosceles, or scalene, we can now look and classify by angles. If it is an equilateral triangle, that's pretty much its own case. Equilateral triangles also all have the same angles. So they are also equiangular, meaning all angles are equal. So angles are equal. But if it's not equilateral, and we want to now classify by our angles, we're going to look at the different angle measures that we have. So classify by angles. And we have, again, three main possibilities. Our triangle could be an acute triangle based on the angles. It could be a right triangle based on the angles, or it could be an obtuse triangle based on the angles. An acute triangle means that all of our angles are less than 90 degrees. So there's not a single angle that is equal to or larger than 90 degrees. A right triangle has one angle that measures exactly 90 degrees. And an obtuse has one angle greater than, actually, I'm just going to write it this way. It has one angle greater than 90 degrees, but less than 180 degrees. So it's bigger than 90 degrees, but it's not a straight line. So looking at an example, we're going to classify each of these triangles by type, or we're just going to actually determine the type of triangle. Determine the type of triangle. Example A, we are going to have a triangle that has three different side lengths. So here's 1, 2, 3 side lengths that are all different. This one is 6 units, this is 7, and this is 8. This angle measure here is 77 degrees. This angle measure is 54 degrees. And this is 49. That doesn't add up. It has to equal 180. But we're just going to roll with it for the sake of this problem, even though I don't think this adds up to 180. But I must have miscopied this problem. So looking at this, if we want to determine the type of triangle that this would be if these angles added to 180, first we're going to look at the side lengths, and the side lengths are all different. So this is a scalene triangle because all of those side lengths are different. And then looking at our angle measures, all of our angle measures are less than 90 degrees. So this is a scalene acute triangle. Part B, this triangle has this side length, which is 4.73 units. It has this side length, which is 4.73 units, and it has this side length here, which is 7.82 units. And then we have this angle here, and this angle is a right angle, and then we have these two opposite angles, which aren't even identified to us. And I can actually name this type of triangle. Looking at the side lengths, I noticed that two of our side lengths are congruent. So that means this is an isosceles triangle. And looking at the angles I have, one of our angles is exactly 90 degrees. It is a right angle, so this is an isosceles right triangle. All right. The last thing I want to talk about is quadrilaterals. We have kind of a hierarchy of quadrilaterals. Okay, first things first, a quadrilateral is any shape that has four sides and four angles. So if you see a shape that has four sides and four angles, this maybe, those are quadrilaterals. Now we can get more specific. Next, we have trapezoids. I'm gonna actually do blue. And trapezoids have at least one pair of parallel sides. So at least one pair parallel sides. So, for example, here's a very basic trapezoid. And here the two bases run parallel to each other. Sometimes you see ones that maybe look like this. So this is also a trapezoid because it is a quadrilateral. It has four sides, four angles, and only one pair of sides is parallel. So quadrilaterals is our big overarching idea, and then we have trapezoids. Then we have parallelograms. Parallelograms have two pairs of parallel sides. So maybe I have shape that kind of looks like this. And these two opposite sides are parallel, and then these two opposite sides run parallel to each other. Or maybe we have something kind of like this. And these two sides are parallel, and these two sides are parallel. So those are our parallelograms. Within the realm of parallelograms, okay, so I'm gonna kind of start grouping things. So quadrilaterals is all of it. So all of these are quadrilaterals. Then we have our trapezoids. Oops. So trapezoids fall within this umbrella. And then within the realm of trapezoids, we have our parallelograms. And now within the realm of our parallelograms, we have rectangles. Actually, I'm gonna do it this way. We have rectangles. We have rhombuses. and we have squares. So what is the difference? All of these are types of parallelograms, yes. Rectangles have two pairs of parallel sides, and they have four right angles. So here is my rectangle, drawing it at an angle for a reason. You can see that all of the angles are right angles, and all of my opposite sides are parallel. Rhombuses have two pairs of parallel sides. They don't have any right angles. Instead, they have four congruent sides. So rectangles have four congruent angles. Rhombuses have four congruent sides. Oops. I'm doing a bad job. Here's my rhombus. Let me draw it this way. This is a rhombus because these opposite sides are parallel. But each side here is also congruent. Lastly, we have squares. And squares are a mix of both rectangles and rhombuses. So squares have, oops, I hate it. Squares have those two pairs of parallel sides. They have four right angles, and they have four congruent sides. So four congruent 90-degree angles. If they are all the same, or if they're all right angles, they are all congruent. So four congruent 90-degree angles and four congruent sides. So here is my square. Ah, not a very good one. Here is my square. It has all of those right angles. So those angles are all congruent. These sides are all congruent. And each set of opposite sides also is parallel. If you ever see a shape referred to as a regular shape, also just for funsies, a regular shape has congruent angles and congruent sides. So a regular hexagon or a regular pentagon is a shape that has, for example, a pentagon would be 5 congruent sides with 5 congruent angles. So please let me know what questions you have on this section, and I look forward to seeing you in class. If I can stop the recording.